Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. Today's subject is the why, what for and how on food equipment and supplies safety certification. Today's guest presenter, first time with us, Larry Levine, Strategic Account Manager at NSF. Welcome. Good morning, Larry. Nice to have you with us.
Thank you, Simon. Thanks for having me.
You're welcome. It's great to have you along. And where are you joining from today, Larry?
Yeah, I'm joining from sunny Tampa, Florida.
And I'm in overcast northern England in Manchester. Where are you from? Do tell us. Patricia from New Jersey. Abdul Rahman from Dubai. Oh, it's been very wet there recently. I've seen pictures of cars with water. Very bad weather, unseasonable. Mayank from India, Akbed from Toronto, Kathy from Ohio, Albert from Texas. You're all very welcome. Okay, so I'm going to play the sponsors ads now, and then we'll be back for Larry's presentation in 1.5 minutes. See you soon. Okay. Sorry about that. Okay, I'll hand you over to Larry now for the presentation. I'll be back for the Q&A afterwards.
Okay. Well, hello, everyone. Thanks for taking the time to listen to this presentation today. As you can see, the title changed slightly, so we're going to be giving you some information on a few sectors within NSF. So perhaps if you are familiar with NSF, then the goal is to introduce you to perhaps previously unknown business sectors. If this is your initial time hearing about NSF, I hope you enjoy the information provided. There's a lot of information that will be spoken about, so please be sure to send in any questions as we work through the presentation. In the late 1930s, Americans began dining out in great numbers, but with little health and safety regulations in place. In the 1940s, some forward-looking scientists came together to establish the National Sanitation Foundation within the University of Michigan School of Public Health for the purpose of sound improvements in sanitation, with the first published standards being number 1 and 2 introduced in the 1950s. NSF is 80 years old this year, an amazing milestone. NSF is an independent, not-for-profit, non-governmental public health and safety organization that develops standards, tests, and certifies products for food, water, health sciences, and consumer goods to minimize health effects and protect the environment. NSF is a totally independent third-party certification body and is completely unbiased, which is often unique to the various industries that we're involved. NSF certification of products is fundamentally voluntary, but it has become synonymous with the various health and safety departments as proof that the products certified provide a basis for safety and or cleanability depending on the category. Most every operational product in the greater food service industry in the United States will likely be certified to the NSF standards. Any restaurant chain, consultant, or knowledgeable operator should demand products certified to the NSF standards. How many companies can really say that they affect upwards of 100% of anything in any business sector? Not many, I imagine. But this is exactly the case in the greater food equipment and supplies industry, which manufactures all the operational products for the hospitality industry, including businesses such as restaurants, bars, hotels, and many other areas. Because health inspectors around the country in the United States look for all equipment to be certified to the NSF standards, this cause and effect statement means that NSF standards directly affect factories, sales representatives, distributors, dealers, service technicians, consultants, designers, and operators. Thus, the 100% effect in an entire industry. NSF works hard to be involved throughout associated industries to create an opportunity for direct communication with NSF, allowing for the opportunity to potentially answer questions, solve issues, or even resolve debate as it relates to the NSF standards. Now, we're going to take a very basic look into food equipment certification. The purpose of the food equipment standards is to establish a minimum food protection and sanitation requirement. The best way to protect public health is using equipment certified to the NSF standards, which, in the most basic description, means that it is hygienically designed, capable of being cleaned, plus can properly store and hold food at safe temperatures. Although the purpose of the food equipment standards is to establish minimum requirements, it doesn't stop anyone from adding features as long as the base requirements are met. NSF standards are not specifications, and they do not tell a manufacturer exactly how to build an item. But the structure of the written standards allows for new and ongoing innovation for all the products. We'll take a quick look at the standards shortly. NSF certified products are the most effective way to demonstrate compliance of the equipment to the U.S. FDA Food Code, which reduces concerns for health regulators. Products stating NSF certified on literature and marketing material is a powerful tool to use as it's a highly recognized certification. However, only products certified to the NSF ANSI standards specifically by NSF can state NSF certified. All other certifications to the NSF standards can only mention compliance or reviewed to the NSF standards. Brand protection is very important, but it can be overlooked. So what are things that might be considered brand protection when a product is certified to the NSF standards? It means that health departments will always accept NSF certified products, that it reduces the potential for negative relations with health departments and environmental auditors, that it reduces the likelihood of foodborne illnesses, that it proves absolute cleanability, that it encourages a food safety culture, that it establishes equipment uniformity, that it safeguards company reputation and mitigates risks, that it protects the customers and employees and thus the brand. Public health and safety are the reasons that NSF exists today, and the NSF standards can often prove out their value in unexpected situations, such as these real-life examples. In 2023, in Washington State, there was a listeriosis outbreak caused by a restaurant that did not clean their soft serve equipment properly. To attain certification, this type of equipment is required to go through a rigorous clean-in-place testing, which guides a health inspector to look past the manufacturer and concentrate on the operator and operational procedures. This is easy justifications to get product certified. Another example was in San Diego, California in 2019 in an actual hospital, whereas the ice given to patients resulted in Legionnaire's disease, causing illnesses and death. Yes, it actually happened in a hospital. This was ultimately caused by poor cleaning procedures by the staff who did not follow the recommended cleaning procedures by the manufacturer. Ice machines must also go through rigorous clean-in-place testing to obtain certification, which again allows the health inspectors to concentrate on policy, not the equipment. The certification process can be very involved, and because NSF receives a lot of very interesting product questions and inquiries, we often don't have a clue what people have. So we always first ask, what is it? This helps us determine what standard the item might fall under and what questions to ask so we can better understand the product and the requirements to get it certified. From there, we typically generate a quote, and upon approval to move forward, we seek a lot of documentation, including things such as a complete parts breakdown, a complete material breakdown, marking information that will go on the unit, specification sheets, drawings, and other things. From there, all the information is reviewed by an NSF technical and sometimes material review team, and where needed, physical reviews and clean-in-place processes must be completed. If and when all the information, technical evaluations, and the possible physical evaluations have passed and deemed acceptable, the product will become certified and gets posted on nsf.org. Getting NSF involved early in the design process can save a lot of headaches, time, and money. As part of the certification process, NSF offers pre-evaluation services, technical and design reviews that can be used during the prototype or initial engineering phases. Using these services at the beginning of the design or prototyping phase allows NSF to advise on the idea, validate the designs, support technical process, and provide thorough evaluations where needed. Another interesting service that NSF provides is called field trials. If a health inspector questions whether a product is actually certified, they can request the product be reviewed by NSF in the field. What generally takes place is a site visit by a member of the NSF technical team to review the construction of the product and to see if it generally meets the requirements of the NSF standards. After review, specific documentation is written and submitted to the health department. However, this document does not certify the equipment, but rather it provides enough information to the health inspector to decide if they will allow the equipment to remain in use. An NSF label stating acknowledging the field review is placed on the unit, resulting in building good rapport with the local health departments because it's recognized that NSF is assisting the manufacturer to make sure the product is compliant. A fun story, I flew into San Francisco, California, and as I was walking off the plane into the terminal, I glanced off to my left and saw a fully automated robotic coffee serving equipment system. It was a kiosk. And I knew that we were heavily involved. NSF gets heavily involved in robotics and the new technologies that are forthcoming in the hospitality industry. So I went up to the unit, and most of the people were watching in fascination, the robots doing their thing. And I, as usual, walked to the back of the unit looking for some information. And sure enough, I saw that the unit was not NSF certified. However, did see another label on there. What ended up happening is this unit was in fact not NSF certified. The health department saw it, and they decided that it was not certified, and they wanted to know if it could be reviewed by NSF. NSF was hired by the manufacturer, went to the job site, reviewed the unit, wrote the documentation on the report on the review of the equipment, sent it to the health department, who in turn obviously accepted the information that we supplied and allowed it to remain in the airport. So that's a great example of a field trial. Combined, there are over 80 NSF standards across 4 subsectors, including food, water, health sciences, and sustainability. The food and water standards apply in many ways towards the hospitality and food service industry, while many retail applications can also be affected by the NSF standards. We'll look more into the standards next. Of the 80 total published standards, there are 21 published commercial food equipment standards. As the titles indicate, each standard is written to capture the different types of equipment and their intended end use. The standards in red are what we often refer to as the core standards, which provide the base foundation which all the other standards are built. In some situations, a product could easily involve multiple standards to get certified. This slide about the NSF standards development process is somewhat confusing, but it's important to take a moment to explain how an NSF standard is generally developed. This flowchart of the standards development process gives a glimpse into the steps in creating a published standard. All the standards are created in what's called the Joint Committee. The committee is accredited by the American National Standards Institute, also known as ANSI. First, a proposal, also known as an issue paper, is submitted for consideration, and this can be submitted year-round because the NSF standards are on a continuous maintenance schedule. The proposal will be reviewed to determine if it can be sent directly to ballot or if it needs further discussion in a task group or at the next Joint Committee meeting. Once reviewed by the committee or task group, the proposal or issue paper might get voted on by the Joint Committee voting members. If approved, it will move forward to ANSI for notification, who in turn will make the proposal available for public comment for up to 60 days. Once it passes that phase, it will move on to the PHC for voting and then a final approval by ANSI. PHC means the Public Health Council, which is composed of representatives of professional organizations, federal and state regulatory agencies, academic institutions, as well as nationally or internationally recognized individuals who have demonstrated leadership in the public health and environmental fields. The general public can review and comment on existing issue papers or can issue a paper suggesting revisions to any of the standards. All Joint Committee meetings are open to observers in person or online. Although there are many more conversations and meetings on any issue paper, this gives a glimpse into the process. Since we understand that NSF standards are the minimum requirements on product design and not dictating specifications, they are primarily considered guides to any design, not necessarily a blueprint that tells anyone exactly how to build a product. The way the standards are structured and organized are essentially the same for all the standards. First, the product is identified as to what it is and how it's to be used. Next, we identify what standard is best suited for that product. Then we evaluate the zones of the product to determine the construction and material requirements for the appropriate standard. And finally, it's determined if any type of testing is required for that product. Now, we'll learn a little bit about the zones. So what do zones mean as it relates to the NSF standards? There are 4 core zones found within the standards: food, splash, non-food, and unexposed non-food. These 4 zones are organized by level of health safety risk. Food zone direct contact refers to parts or areas in equipment that come in direct contact with food or liquid that will be consumed. Food zone non-contact simply means that food or condensate could drain, drip, or splash back into the food or food contact surfaces. Splash zone surfaces mean that the areas are subject to splash, spillage, or food soiling. The non-food zone is very simply defined as visible exposed surfaces not in the food or splash zone. Here is a more specific picture to allow for perhaps a better understanding of the zones that we just spoke of. Whereas the griddle surface would be considered food zone, meaning the surface will come in direct contact with food or liquid that will be consumed. The front of the equipment stand is considered a splash zone surface, where again, it may incur spillage or food soiling. And finally, the non-food zone being described as visible exposed surfaces not in the food or splash zone. The design of equipment takes many things into consideration, and many of which are logical and obvious. However, there are also things not as obvious that the NSF standards take into consideration, which can affect if the product can be certified. Those things include, but are not limited to, confirming that the equipment design ensures cleanability, verifying that food-safe materials are used to ensure they are non-toxic and don't leach into consumable food, performing tests of equipment to certify that it keeps foods at safe temperatures and doesn't harbor bacteria. It's taking a close look at seams and joints and internal angles at corners to confirm things are tight-fitting, sealed properly, and the required radius is met. It's verifying that any fasteners and hinges have the required ability to be disassembled and remain easily cleanable. It's verifying that mounting of the product is either movable on casters, sealed to the mounting surface, or has required sufficient access to clean underneath. Casters must prove out to be easily cleanable, even though they are not in direct contact with food and are very difficult to get certified. Physical evaluations are a very important part of the certification process and occurs on many products with some standards having much more invasive evaluations than others. You can imagine that the physical evaluation of a thermometer or of a frying pan is much different than a dishwasher or a soda dispenser. So what then are examples of what NSF is looking at when physical evaluations are performed? Well, we look at the applicable design and construction requirements based on the type of unit, and it's reviewed and confirmed to meet the appropriate NSF standard. We confirm the zones are verified so that the unit meets the zone requirements throughout the product. capturing and verifying that all the materials used to make the product are on what's called a certification parts list, or a CPL, to ensure the material requirements are compliant and safe to use. And it's to confirm or identify any potential testing that could be needed, such as temperature requirements, clean in place, or other factors. Performance testing often follows physical evaluation and can involve many things, including, but not limited to, food holding tests in refrigeration units or hot holding equipment, clean in place, which proves out that the manufacturer's cleaning instructions completely get rid of bacteria within the operating system, temperature accuracy, both on equipment itself, such as in a hot holding well, or an actual thermometer. You'd be surprised how difficult it is for thermometers to meet the NSF testing standards. So when you want to buy a thermometer, you should really look for the NSF label, as it's proven to be accurate. Organic coatings that might be used over things like shelving are tested for impact or abrasion effects to make sure they stay on the designed product under duress. Heavy metals such as lead are tested for within certain types of equipment, especially where water is involved, to determine that the lead is at a safe level. And then, of course, cleanability of anything being offered on the market today. Previously mentioned materials means that products must be constructed of acceptable and safe materials. All primary or base materials for products must be what NSF terms as smooth, whereas a material must be free from rough edges or surface imperfections, such as pits or pinholes that are detectable by visual and tactile inspection. Textured materials are viewed as any material with a visual pattern surface that may hinder removal of soil from the surface. However, this type of product can meet the cleanability requirements and has been approved for uses such as floors or walls in walk-in boxes and other applications. Porous materials are such that the surface is not easily cleanable, and can potentially have absorption qualities which are never allowed on any product. Easily cleanable is a very important term throughout the written standards and will always be emphasized, and simply means that the surface can be cleaned by manual cleaning methods. In other words, it can be cleaned by hand with appropriate cleaning tools. An interesting area that NSF puts great effort into is material formulation toxicology, which is the evaluation of formulations of ingredients that make a base food zone material used in the products. For example, when you look at a green plastic serving tray, NSF Standard 2 requires that all the materials are safe from leaching into food that can be consumed. NSF takes the time to evaluate each and every material to confirm that it is safe to humans. The evaluation of these ingredients can sometimes be a long process, but there are many formulators that get their materials 21 CFR approved or NSF 51 certified to make their product more inviting to specify by manufacturers. Although it may seem simple, making sure the materials used in the construction of product is always safe, and this absolutely includes corrosion resistance. The definition of corrosion resistance in the NSF standards are defined as materials that must maintain surface characteristics under prolonged contact with its intended environment and exposure to cleaning and sanitizing solutions. The intended environment is where and how it's supposed to be used in its intended design. To provide some additional views into what NSF is seeking in the design of products, we'll look at some slides to show examples of product compliance versus non-compliance. On this side, we show where drain boards must slope back towards an area with a drain, such as a sink tub or a trough. Levels are used to determine that the minimum required slopes are compliant within NSF Standard 2. Here is an example of stainless steel fabrication, whereas on the left, it's clear that the seams are not sealed correctly, allowing gaps that can harbor dirt and vermin and cannot be cleaned. The picture on the right shows proper seals with no gaps and having all the required radius for ease of cleaning. This is an interesting example because again it proves the level of detail and requirements within the NSF standards. Welds are difficult to apply in many cases, and as you can see, the picture on the left clearly shows a weld that is not smooth and cleanable, whereas the picture on the right is perfect. It's smooth and can be easily cleaned. You would be surprised how many products are sent to NSF for physical reviews and have welds similar to the picture on the left. These are obviously quality control issues at the factory and are easily rectified. Often an area that some might look past are equipment legs and feet, but they also have very specific requirements within NSF Standard 2. To meet compliance, these products cannot have exposed threads and, like everything else, must be easily cleanable. Exposed threads are interesting because you don't normally think of this as not acceptable, but when you consider how much dirt can accumulate in threads, it all of a sudden makes sense not to have them exposed. The picture on the right shows an adjustable foot or leg where the threads are clearly hidden within the leg. So now we're going to take and move on to other areas that NSF excels at. One extremely important area that NSF specializes is in the water filtration and water safety sector. Like the food equipment standards, NSF also facilitates the development of many public health standards for water quality that are adopted by state and federal health codes to protect drinking water and pool safety and pool and spa safety. Yep, pool and spas too. A good example that many of you may recognize is something we call inline filters that you might see on the back of things like ice machines, coffee makers, and water fountains. These filters concentrate their effectiveness using NSF standards 52 and 43, which apply towards what's called drinking water health effects. Other water quality areas that NSF standards address are technologies such as ultrafiltration, activated carbon, reverse osmosis, ultraviolet, water softeners, and other areas. In the 1990s, NSF became a collaborating center on drinking water safety and treatment, by the World Health Organization. A great story about water quality in NSF involves the city of Flint, Michigan in 2014. The city of Flint, Michigan had a public water crisis where the water was shown to have been contaminated with lead and possibly Legionella. Many illnesses and possibly some deaths were attributed to this outbreak. Although many companies approached Flint, Michigan with solutions that they wanted to sell to the city, Flint approached NSF to see if we were willing to help. And help we did. It was the NSF scientists and laboratories that determined cause and solutions, resulting in identifying product types and specifications that could resolve the issue. These solutions were specified and eventually implemented, and today, solving Flint, Michigan's issues. The state of Michigan will now only seek guidance from NSF for anything relating to water quality. Some other things that you may not have known about NSF are our involvement in Energy Star and NRTL electrical certification. NSF is a fully accredited testing lab and certification body for the EPA Energy Star program. NSF can test and certify from our own labs, or we can certify and report the testing done by other accredited labs to the EPA's Energy Star program. Recently, it was suggested that the Energy Star program may expand to become mandatory in certain product sectors throughout the United States. NSF is also a fully accredited electrical certification body for OSHA's NRTL, which is the National Recognized Testing Laboratory. The NRTL is the actual body that oversees all electrical certification. Similar to equipment certification, NSF can advise on electrical designs and prototype long before the actual certification process occurs, which usually equates to 100% compliance once the actual certification evaluation is done. This can save a lot of time and money. Now, we're going to shift a little to talk about available education classes on some NSF standards. For many years, manufacturers and others have asked how they can learn about the NSF standards, but NSF didn't really have a great solution outside of just sending the standards booklets and letting them read about it and then asking us questions. Enough requests came in for NSF to develop a better strategy. So finally, in 2024, NSF began introducing some self-guided training courses for food equipment certification with the goal of gaining a better understanding of certification compliance relating to product design. The first course involves standards 2, 51, and 170. As shown on an earlier slide, standard 2 incorporates all the base designs of food equipment, including things such as stainless fabrication, cooking utensils, thermometers, equipment-based construction types and requirements, food shields, and many other things. NSF Standard 51 incorporates all the food equipment materials that can be certified. These include materials such as polymers, plastics, colorants, ceramics, and many other products. NSF 170 is the glossary that explains the meaning of all things associated to all the standards. Often a product being certified can include reference to all three of these standards, in addition to a primary standard that the product might fall under. For example, if it's cooking equipment that falls under standard 4, it can require compliance to standard 2 and to standard 51, and then use standard 170 to clarify things. So what will be learned? Gaining better understanding of the NSF food equipment core standards 2, 51, and 170, and gaining the knowledge and skills needed to navigate the requirements of the standards and certification processes. Who might be these trainings designed for? Well, a lot of people, including restaurant owners, managers, chefs, food handlers, caterers, anyone who interacts with food equipment on a daily basis, food manufacturers and food processors, food safety and quality assurance personnel, equipment purchasing managers and buyers, food equipment consultants and designers, health inspectors and regulators, and food equipment manufacturers and suppliers. Another great example of the NSF family of certifications is non-food compounds. As you can see on the slide, the non-food compound program verifies the safety of chemical products used in food processing. The chemicals that are utilized in the manufacturing process, but are not intended to be added intentionally to food, is how this applies. Some examples of non-food compounds are cleaners used to clean or sanitize the surface of a food preparation equipment, along with food-grade lubricants, which are intended to reduce friction in any moving parts. The food-grade lubricants must be proven safe for human consumption if an unintended result is coming in contact with food during a manufacturing process. A food-grade lubricant is also called an H1 lubricant. NSF has worked together with the USDA and the non-foods compound program for a very long time, proving again the trust that organizations like the USDA have with NSF and our concern for human and planet health. NSF has something called the NSF whitebook, which is an online listing directory to identify H1 food lubricants and other products. This listing tool is generally considered for food and beverage processors to confirm any product necessary for their business is a registered product, but it can be accessed by anyone. Currently, there are over 380,000 page views per year and over 13,000 registered H1 lubricants. The non-food compound evaluation for registration is formulary-based. So NSF does not perform factory audits, and in this case, rarely does actual product testing. However, product label to verify accuracy, including acceptability of all ingredients, formulation and mixture acceptability, trade name verifications, ingredient and language statement verification, compliance verification to 21 CFR and 40 CFR, along with some other things. CFR officially means the Code of Federal Regulations for the Protection of the Environment and is used to prove, amongst other things, that certain chemicals cannot harm humans or the planet. This is an example of a certificate of registration which is valid for the calendar year and can be renewed annually. The registration certificate is valid through the calendar year and remains valid as long as the product is listed and a downloadable letter is posted on the whitebook website and nsf.org. Now we'll take a brief look into the NSF Green Chemistry program as part of the non-food sector to again elaborate the diversity of NSF and the concern we have for human and planet health. Our green chemistry team supports the EPA with what's called the Safer Choice program. This is a voluntary program that encourages the use of safer chemicals without sacrificing performance. The program is administered by the EPA. However, the toxicology work is primarily managed through third-party profilers. NSF is a leading profiler of the EPA's Safer Choice program and the Clean Ingredients program. The programs are broken out as two main offerings, being Safer Choice for the finished products and Clean Ingredients for the ingredients that are intended to be used in the Safer Choice products. So what is the Safer Choice program? It's a voluntary program administered by the US EPA, which developed the Safer Choice standard and manages the overall program. The Safer Choice label helps consumers and commercial purchasers find products that contain safer chemical ingredients without sacrificing performance. NSF partners with the EPA to perform third-party evaluation of products and audits the program and is the largest reviewer of the Safer Choice program. As reviewer of the programs, NSF performs toxicological reviews of the products and their formulations to ensure that products do not contain chemicals of concern, such as carcinogens, or reproductive or developmental toxicants, to ensure that products are safer for you, your family, your pets, and the environment. The program has a few different logo options, as you can see on the slide, for consumer use, industrial and institutional use, and for fragrance-free products. The Clean Ingredients database of chemical ingredient formulations has been pre-approved by the US EPA to meet criteria of their safer, of their Safer Choice standard and can be easily accessed by anyone. The Safer Choice program includes many product sectors for both consumer and commercial products, such as all-purpose cleaners, dish detergents, glass cleaners, hand soaps, laundry products, floor cleaners, vehicle washes, and ice melts. A complete list of product types can be found on the Safer Choice website. Due to overlap in product types, NSF has crossover clients between the non-food compound registration program and the Safer Choice program. Some examples of this crossovers are something that we call Category A, which is cleaning products, and Category B, which are laundry products. Another example is Category 3D, which is fruit and vegetable washes, or E1 for hand washing products and other categories. I'll pause here for a moment so you can scan the QR codes if you're interested to get more information on the non-foods program and ISO 21469 Safety of Machinery Certification Program. NSF is involved in multiple types of ISO certifications of operational safety also. So please just let us know if we can answer any questions. Thank you for allowing me the time to chat with you today, and I hope you gained some new insights into the NSF capabilities.
Okay, thanks very much, Larry. Let's pick up on questions. Let me just get rid of the slides. Just bear with me. Okay. Oh, I don't know who that is there at the bottom. Another Larry Levine.
Yeah, two of me. Yeah, two of me.
Right. Okay. Questions, everybody. There is one from Victoria. If a product is certified by NSF, does it mean it complies with EC 1935-2004, EC 2023-2006, EC 10-2011?
Sure. So you're talking about European certifications. So there isn't anything quite like NSF in the European Union. However, we do have another sector that we have created on behalf of the EU. Interestingly enough, there are some EU countries that are beginning to think about applying the NSF standards, but that may be, that's a little bit way off into the future. But we do have a program dedicated to the EU. We are also heavily involved right now in helping South Korea develop standards for the first time. We're assisting India in helping develop standards for the first time. So we have an outstanding European team that we'd be happy to get in contact with you and help explain what we can and can't do on behalf of equipment over there.
Okay, excellent. Any further questions? Shamina, very good presentation. Pete, very informative. Thank you. I've got a question from Yusuf. Is the NSF certification, should it be included in the ISO 22000 system?
If I understand your question correctly, I think the ISO certifications you're talking about and equipment certification are two totally different things. The ISO certifications, again, if I understand your question correctly, are directly related to the processes in food processing facilities, equipment manufacturing facilities, all kinds of facilities, anywhere where ISO certification should be considered. But the NSF certification of products such as equipment or water, different. So hopefully I answered that the way that you asked it, and hopefully it made sense.
Makes sense. Question from Anurag. Do NSF standards help in developing sustainable food systems, and how?
Yeah, so Actually, so it's not spoken about in this presentation. NSF has a huge presence in the food and food verification sectors, including things like organics and non-GMO, and we have major involvement in the tracking of food quality products. So we do have a large sustainability-based sector for food. We have a phenomenal team. We do audits across the world on everything from food producers to operators. So let us know how we can help. Send us over an email, and we will find out where you are, and we'll get that team in contact with you, and they can give you much more detailed insight on what they can do.
Okay, great. Question from Ravi Kumar. NSF certification for food contact surface of equipment, is it mandatory or voluntary?
Yeah, it's absolutely voluntary, and so often people look to NSF to answer questions, but because it's a voluntary act and it's not anything that any governmental agency is demanding, we don't dictate anything. Everything now. The reality is, health departments around the country and in Canada and in other countries use it as a basis to say, if it has this, then at least I know that I don't have to worry about the basis of design and cleanability for those products, so that they can concentrate and look towards other things, right? And it also helps them, and in some cases, it helps them. Like I talked about the field trials, it can resolve an issue with field trials. So hopefully that answered the question. Again, it's a 100% voluntary thing, but again, health departments and inspectors kind of expect it, so there's kind of some duplicity there.
Ronald asking the differences between NSF and BRC in terms of certification.
Yeah, I'm not sure what that is. I apologize. I wish I could answer your question. I'm not sure what BRC is, so my apologies to you for not knowing.
Yeah, BRCGS, British Retail Consortium, GFSI standards, for management food safety systems is a different thing altogether. Yeah,
we do a lot of auditing for GFSI here in the United States, and we do it in other parts of the country. Our audit teams are very involved, and sorry for not knowing the BRC term, but GFCI I recognize. So our audit teams and our retail teams are very involved in field audits and what have you in the GFSI sector. So we do get involved with that. Yeah.
Different thing altogether. From John, question: in Ohio health departments, do they require equipment to be certified by a body like NSF?
The answer would be that probably yes. It's not mandated of any health department to apply NSF standards to equipment. And often equipment shows up in places without any type of NSF certification. There's even categories of product that are all throughout the United States that have no ability to be NSF certified because they can't meet their material requirements. So it's up to a health inspector on whether or not they're even going to allow it. So the simple answer is yes. Ohio is a major, in fact, I think they're one of the more major interactive states. We have a lot of communication with state health departments throughout the country. From memory, I think Ohio is one of the major contributors of questions and answers and things like that.
Okay. One more question from Victoria. Does the NSF standard contain migration tests?
I don't believe so. I don't recognize migration tests as part of the only part that it might be involved with. I'm thinking about a migration test might be in the formulation, so like material formulation and things like that. Migration might be involved in those evaluations and those tests.
Okay. Okay, that's it. Got through it with a few minutes to spare. So thanks very much, Larry. Enjoyed that. Nice update and appreciate it. So hopefully you'll be back again sometime to see us.
That would be wonderful. I would enjoy that immensely. So, if there's any other questions, let me know, and I'll do my best to answer them.
Okay, brilliant. Thanks very much, Larry. Enjoy your weekend.
Thank you. Take care.
Bye-bye. Okay, ladies and gents.